All right, part 3. We're going to talk today about holes and slant asymptotes. All right, when you guys are finding holes, there's going to be a way that I want you to answer it. WebAssign's going to have you answer it a little bit of a different way, so I'll show you guys on the last slide how to do that. But when a hole occurs, it's generally where an asymptote, you would think an asymptote was, but it's because that there is not a vertical asymptote at this point. It's just an actual hole in the graph. So if you notice here, like in this picture, do you see how there's a hole at x equals 2? The graph continues on either side of that. It's not that there's an asymptote that says, oh, it doesn't go any further, or it doesn't touch this line, or it gives you a different look of it. There is a hole there, there's a break in the action, so to speak. So I'm going to give you guys this question here. Let's just say we have f of x equals x plus 2 over x squared minus 4. Okay, x plus 2 equals x squared minus 4. If you guys were going to go through like we did the other day, yesterday, day before, whatever, and tell me the domain and the vertical asymptotes, where would we look? The bottom, right? X squared minus 4 equals 0. You guys would add 4 to both sides, right?
Could you say that again?
No, Siri, I can't. And then we have x squared equals 4. Take the square root of both sides. You guys get x equals plus or minus 2, correct? You guys with me? So you would tell me that your vertical asymptotes are at x equals plus and minus 2. And then you would tell me the domain is negative infinity to negative 2, negative 2 to 2, and then 2 to infinity, correct? Now, the reason you have to look for holes is because it will affect your domain and your vertical asymptotes. It'll also affect your graph. You guys are not going to have to graph holes on your test because it's just, sometimes it's very hard to figure out when you're doing it all by hand, so we'll just know that. But if you have a hole, this is what happens. Look, we're going to factor x plus 2 on the top, correct? Then on the bottom, I have x plus 2, x minus 2. You guys agree? Yes? Do you see something that is exactly the same?
Yes.
What?
X plus 2.
X plus 2 on the top and bottom. So you would cross that out and you would say there's a hole at x plus 2 equals 0. So you would tell me the hole is at what x value? Negative 2. Now, how does that affect your answer? So if you're going to answer your vertical asymptotes, you only have one vertical asymptote. Your vertical asymptote is at x equals what? 2. You don't have a vertical asymptote at negative 2. Where is your vertical asymptote? Just at positive 2. What's occurring at negative 2? There's a hole. So like on WebAssign, you're going to go through and you're going to find on some of them that you have 2 asymptotes. But then when it says where is the hole, you're going to be like, oh, wait, there's a hole there. So then you don't account for that asymptote because there's actually not a vertical hole line there. It's just a hole.
So if there's not a hole, it would still be plus
Then,
or
yep.
minus?
If there's not a hole, then it's whatever. It's if you find your asymptotes and then a hole occurs at that same spot, then you don't account for that under your asymptotes. Now, that's how I want the question answered, right? I want to know where the hole is, your x value. WebAssign is going to ask you for an xy value. It's going to be like this, xy. So you guys are going to tell me negative 2, 0. It actually doesn't occur at negative 2, 0. It occurs where negative 2 is the x value. How do you figure out what the y value is? Then you would plug this into the factored form. And I'm going to show you an example of this in a second. So this would be 1 over x minus 2. So it would be 1 over negative 2 minus 2. So your hole would occur at negative 2 comma negative 1/4. But again, I'm not asking you to answer it like that on the test. On your test, you just cross off what they have in common, and then you tell me what the x value where the hole occurs. I'm not asking you to plug it back in, but WebAssign's going to ask you to do that. I'm going to show you at the end of this. Yeah.
So in WebAssign, we have to plug back in?
Yeah, I'll show you. But on your test, I just want to know the x value of where the hole is. Okay, so we talked about holes here. Right. This is they say 7-step method on how to graph. This is just using your cheat sheet, guys. To find the y-intercepts, you plug in 0 for x. That's how you find y-intercepts everywhere. To find the x-intercepts, if you look at your cheat sheet, it says put the numerator equal to 0. You're going to just factor it, all right? So we're going to go through and talk to you about graphing here and then we're going to talk about slant asymptotes. If you were to graph, you'll have one question on your test that says, okay, find all of the stuff. Domain, vertical asymptotes, horizontal asymptotes, slant asymptotes, x-intercept, y-intercept, and holes. And then you got to graph it, right? This is why your cheat sheet is so important. Somebody asked me last period, are you going to give us the cheat sheet? No. And I'm going to tell you when a slant asymptote will occur. You guys can know whether a slant asymptote is happening or not when you just look at the initial problem and how to answer that question. It's super simple. But let's go through this. Let's answer all these little questions. Where do I look? How do I determine what the domain is? The denominator, right? So I have x minus 2 equals 0. So x cannot be what number? X cannot be positive 2. So your domain is anything in the world except for positive 2, correct? There's your domain. What is your vertical asymptote? X equals 2, correct? What's your horizontal asymptote? How do we figure that out? You're going to compare degrees. Good. So your N and your D. What's the degree of the numerator? 1. What's the degree of the denominator? 1. 1 is what to 1? Equal to. So what does that mean? Leading coefficient over of the numerator, leading coefficient of the denominator. So 5 over 1. So you have a horizontal asymptote at y equals 5, correct? If you have a horizontal asymptote, you will not have a slant asymptote. Let me repeat that. If you have a horizontal asymptote, you will not have a slant asymptote. Here's the reason why. How do you find the slant asymptote? What's your cheat sheet say to do? Long division. So x minus 2 is on the outside. 5x is on the inside. If I say first term into first term, x goes into 5x how many times? 5 times, okay? The way that we answer slant asymptote is in y equals mx plus b form. So if I were to write my answer here of 5, and I'll talk more about slant asymptotes in a second, would you guys agree with me that this would be y equals 5? Where do we already have that as your slant asymptote? Your horizontal. The only time you'll have a slant asymptote is when the numerator degree is bigger than the denominator. If you ever have a horizontal asymptote, whether it's y equals 0 or y equals any other number, you will not have a slant asymptote. We're going to talk more about this in a second and also tomorrow when we're doing all of our graphing, but your slant asymptote is none. Look at your cheat sheet. How do you find x-intercepts? X-intercepts. Set numerator equal to 0. 5x equals 0. So x equals what? 0. So how do I write my x-intercept? 0, 0. We always write intercepts as ordered pairs. What does your cheat sheet say to do for y? How do you find your y? Okay, what does that mean? Plug in 0. Look, guys, if I plug in 0 here and I plug in 0 here, I get 0 over negative 2. What does that give me? 0. So my intercept is at 0, 0. And then how do I find my holes? I factor the numerator and the denominator. So if I factor the numerator and the denominator, is there anything I can take out that's exactly the same or anything? No, you have 5x over x minus 2. So do you have any holes? No. None. All right? You should be able to, by the time you're done with the review, you should know where to look for all of this stuff. You have to practice it. So now we're going to talk about graphing. All right, first thing I'm going to do is put my horizontal and vertical asymptotes on here. So I have a horizontal asymptote at y equals 5. So, yep.
Would you do the long division for it?
I'm going to, with a slant asymptote. I'm going to go over that in just a minute. This is a real basic graph I just want to show you real quick. So y equals 5. 1, 2, 3, 4, 5. Okay. Just a boundary line. And then I have a vertical asymptote at 2, correct? Where were my intercepts? Where does the graph cross? 0. Okay, so I know it's going to be somewhere around here. Now, when you have one vertical asymptote, one horizontal asymptote, you're creating 4 sections. Do you guys see these sections? I have one up here, one down here, one over here, and one over here. Do you guys see what I'm talking about when I reference that? Okay. So your boomerangs are going to exist to the left and to the right of your vertical asymptote. You'll be able to tell. This is the hardest part of graphing, is you guys plugging in and figuring this part out. So if I look to the left of this horizontal asymptote, I mean the left of the vertical asymptote, over here. Do you guys see what I'm talking about? I'm going to pick any number on the x-axis, and I'm going to plug it in. In this case, I don't really have to do this because I already see where my intercept is. But to the left of my vertical asymptote, I'm going to have a boomerang. It's either going to be up here or down here. How do I already know where this one exists? Because of the intercept. I already know that my boomerang is here because I already know where my intercept is. So you're going to draw, you're going to get real close to your vertical asymptote, you're not going to touch it. You don't have to find any exact points, no, because you're doing this by hand. Now, where does the other one exist? It's either going to be up here or down here. I got to figure out where that is. So this is when we're going to plug in a point. Plug in any point, any number over here that's to the right of your vertical asymptote. Pick a number. 3. That's fine. So we're going to plug it into our function. So I have 5 times 3 over 3 minus 2. You guys agree? Okay, so 15 over 1. Where is 15 over 1? Is it above that yellow horizontal line or is it below it? It's above, so you know that your other boomerang is up here. You guys do not have to be exact. You just have to be in the general area because you're not using a graphing calculator. I do not need you to be exact, but you need to know the general area. Now we're going to talk a little bit more about slant asymptotes here in a second. But on your test, you guys are going to have a bunch of questions. You're going to have 1 or 2 that's like this, that says answer everything. The rest of them, I'm going to give you a rational function and say, for this one, tell me the slant asymptote. Then I'm going to give you another one that says, for this one, tell me the domain of the vertical asymptotes. Then the other one's going to be, find the x-intercepts. That's just one thing at a time. But you will have one where you have to do everything. So that's what we're going to practice a lot of tomorrow. Just all class period, we're just going to practice that. I changed the order of the slide. Go to this slide where it says slant asymptote. Now, the only time you have a slant asymptote, guys, if you remember this, it's great. But the only time you have a slant asymptote is when the numerator degree is bigger than the denominator. When the degrees of the numerator is bigger than the denominator. That's when you will have, if it's equal to or less than, you will not have a slant asymptote. You always answer in y equals mx plus b form. You will always have y equals. The remainder you don't include. So you are probably going to have a remainder. Anytime you do these, you do not include it in your answer. I want you guys to understand that. So if you're going to do a problem, it says find the slant asymptote. Notice the degree. What's the degree of the numerator? 2. What's the degree of the denominator? 1. 2 is bigger than 1, right? The reason why the numerator degree will always be bigger in a slant asymptote is because when you divide, you have x into x squared plus 6x plus 2. First term into first term, right? X goes into x squared how many times? X times, okay, so x times x is x squared. Bring down your 6x. First term into first term. X goes into 6x. How many times? X goes in, okay, plus 6. So now we subtract. Bring down. What is 2? 2 is your remainder. How do you answer slant asymptote? Do you include your remainder? No. So your answer for your slant asymptote would be y equals x plus 6. If you have a slant asymptote, it's going to be a line. If you graph this, your intercept will be at 6, and it goes up 1 over 1, up 1 over 1. It's going to give you a slanted line. But you do not include a remainder. But the only time you have a slant asymptote, guys, is if the numerator degree is bigger. In the last example we just did, the degrees were the same, correct? So when you went to divide into it, x went into 5x 5 times. You got y equals 5, which was your horizontal asymptote. So the only time you'll have a slant asymptote is when the numerator degree is bigger than the denominator. So let's look at this one. Don't get fooled by anything, guys. This says x cubed minus 1 divided by, so x squared plus 2x plus 2 is on the outside. And then on the inside, I have x cubed. Do I have an x squared? No, so I'm going to put plus 0x squared. Do I have an x to the first power? No, so I'm going to put plus 0x, but I have minus 1. Now remember, our slant asymptote is y equals mx plus b. So I'm going to say first term into first term. X squared goes into x cubed how many times? X times. So I'm going to put it up here. Get your subtraction ready before you multiply. X times x squared is x cubed. X times 2x is plus 2x squared. And x times 2 is plus 2x. Now we have to distribute, right? So I have negative 2x here. I have a negative 2x squared, and I bring down my minus 1. So first term into first term. X squared into negative 2x squared. Negative 2. Good. Negative 2. Do I have to keep going? Yes or no, guys? No, because watch. I have negative 2x squared. Then I have minus 4x. And then I have minus 4, right? So I'm going to distribute. What is all of this stuff that's down here? This is a remainder. I have nothing else to pull down. This is my remainder. Once you guys have your x value, your slope, and then your constant, your y-intercept, you can just stop there. If you want to keep going, fine. But how would you answer this question? It's y equals x minus 2. You will probably always have a remainder, and that is fine. The remainder means nothing. You have to have something with an x and a constant. If you don't have a constant, if you have an x but no constant, then it's just 0. Yes, ma'am? Yep. As soon as you get that remainder, just stop. So when you guys are graphing, when you're doing these problems, you should have this cheat sheet right next to you the whole time. You need to know, okay, this is where I look for this. This is where I look for that. This is where I look for this. You've got to get in the habit of doing it. So you understand how to answer the question, you understand where to look, and you're not spending time trying to remember. This needs to be like quick because you're going to have to do all this on your test. So if you have a question like this and it says use the 7-step strategy, right? You'll have one of these on your test next week and it's going to say, all right, tell me the domain, vertical asymptotes, horizontal asymptotes, slant asymptotes, holes, x-intercept, and y-intercept. A lot of this stuff you can answer without looking at it. I mean, with looking at it, but without doing anything. What are some things that we could look at and just kind of answer off the top of our head? How do you find x-intercept? Set the numerator equal to 0. How do you find y-intercept? You plug in 0 for all of the x's. Like that kind of stuff you guys can do. Yeah. That kind of stuff you could just do just by looking. You can see, I can look at this and say, oh, there's no holes. How do I know there's no holes?
Because if you factor...
You got to factor, and then whatever crosses out. Like these are the type things that you guys need to look at a problem and go through in your mind and be like, okay, there's none of this, there's none of that. That means you know what to do and where to look. If you just want to go down the list, that's perfectly fine. Let's talk about domain and vertical asymptotes. Domain and vertical asymptotes, we do what? We set denominator equal to 0, correct? So x squared minus 25 equals 0, so x squared equals 25. Take the square root of both sides, so x equals what? Plus or minus 5. So you found out that you have vertical asymptotes at x equals plus or minus 5. So I know my domain is everything but those two numbers. So negative infinity to negative 5, union, negative 5 to infinity, just kidding, negative 5 to positive 5, union, 5 to infinity. Horizontal asymptote, where do we look? The numerator and the denominator degree. So horizontal asymptote, numerator, denominator. What's the degree of the numerator? 2. What's the degree of the denominator? 2. 2 what 2? Equals 2. So how do you find if the degrees are the same? Leading coefficient of the numerator over the leading coefficient of the denominator. So y equals 2. Okay, perfect. You already have your boundary lines there. That's great. Slant asymptote. I can look at that and say, I don't have a slant asymptote. Why? Because you have a horizontal asymptote. Good. Because the degrees are the same. But look at it. If you were going to do long division, you have x squared minus 25 into 2x squared. How many times is x squared going to 2x squared? 2 times. So if you were to write this with no remainder, because the remainder doesn't matter, you have y equals 2, which is your horizontal asymptote. So you can look at the beginning and say yes or no to a slant asymptote. What you find the horizontal, you can say yes or no to a slant asymptote. So your answer here for slant asymptote is none. There isn't one. That's fine. What about holes? How do we find holes? You factor. So I have 2x squared over x plus 5, x minus 5. Is there anything that is exactly the same on top and bottom that cancels out? No. So your answer for holes is none. Remind yourself again, x-intercepts, what do? Numerator equal to 0. So 2x squared equals 0. If you solve that, what's x equal? 0. So your intercept is at 0, 0. Y-intercept, you plug in 0 for x. So I'm just going to go up here and say, okay, well, 2 times 0 squared would be 0 over 0 squared minus 25. So 0 over negative 25, what does that give me? 0, so your y-intercept is 0, 0. There's not an exceptional amount of work to be shown for these problems. Y-intercept, you plug in 0 for all the x's.
What about the x?
You set the numerator equal to 0.
For when you're doing the horizontal asymptote, what happens when there's no variable in the numerator?
Like if you had like 6,
Yeah.
this would be x to the 0 power. Good question. All right, so now let's go through the graphing part. This is where you guys are going to be like, it is so annoying. I get it, it is. But you're going to be fine. Let's put our asymptotes on our graph. I have vertical asymptotes at positive and negative 5. So 1, 2, 3, 4. This is what you guys are going to have to do. At least one of these on your test. You need to understand how to find the stuff that I'm asking you to look for, and then how to put it on the graph. 1, 2, 3, 4, 5. What do we know about our vertical asymptotes in our graph? The graph is never, ever, ever going to do what? Cross the verticals. Might cross the horizontals, but it'll never cross the verticals. So I have a horizontal at y equals 2. Yeah? So here. All right, this is where I really need you guys to pay attention. We're going to use those vertical asymptotes as boundary lines. We're going to figure out where our boomerangs exist. When you have two vertical asymptotes, you're going to have boomerangs on the outside. They'll either be here or here. On the right-hand side, it's either going to be here or here. On the left and the right, it'll never be exactly the same. It's either one or the other. And then in the middle, you're either going to have a parabola, could go this way, or you're going to have a snaky thing. Could go either way. So we got to figure out where the graph exists and kind of the shape of it. You'll understand what I mean here, hopefully in a second. Look at your vertical asymptote, your first boundary line over here to the left. Do you guys see it right here? All right, so do you see, as I'm pointing that out, values on the x-axis that are to the left of that? What's to the left of that? -6, -7, -8, -9. You guys agree? Okay. So you're going to pick up something on the left-hand side of that asymptote. It does not matter what it is. It cannot be the asymptote because your graph doesn't exist there. but any number to the left. And then you're going to figure out where that point falls. Is it above the horizontal asymptote or is it below? That's where your boomerang will be. So pick a number to the left of x equals -5. What's a number to the left of -5? -6, okay? I'm going to plug in -6, and I'm going to see what happens when I evaluate. All right, so we're going to plug in -6 and see what we get out. So I have 2 times -6 squared over -6 squared minus 25. You guys with me? Okay, what's -6 squared? Times 2? 72, okay? Over, what's 6 squared? -6 squared. 36 minus 25 is 11, all right? How many times does 11 go into 72 without going over? 6, so this is 6-ish. I don't really need to know exactly where, because we're trying to figure out where this point exists. The point -6, 6-ish, is it above your horizontal asymptote or below it? It's above, it's up here somewhere, right? So you know that your boomerang on this side exists over here. So you're going to draw it close to your vertical asymptote, but not cross it. Don't worry about, sometimes they do cross. Don't worry about that right now. You guys are not graphing with graphing calculators or anything like that. So just the general area is all I'm looking for. All right, now we go to the middle. The middle's a little, not harder, but you got to do a little more work because you don't know what the shape is going to be. It could be a snake, it could be a cubic, or it could be a parabola. So the first thing I like to do is say, okay, well, where's my intercept?
0, 0.
It's at 0, 0. So I know it's either going to be like this or it's going to be a snake, but it's not going to be a parabola in the upper section. So now we're going to pick points in between the two white lines. I would do one to the left of the x-intercept and one to the right of the x-intercept. But what number could we use? It's easy.
1.
Okay? -1 and +1. So I'm going to plug in -1. I'm going to plug in +1. So I'm going to say 2 times -1 squared over -1 squared minus 25. Well, what's -1 squared? 1 times 2. So I have 2 over -24. Do you guys agree? You can simplify it if you want, but you don't have to. Where is -1 comma -2/24? Is it above that horizontal asymptote or is it below it? It's below, somewhere like here-ish. That's fine. Now let's do the same thing with 1 and see what kind of shape we are creating. If I plug in 1, I have 2 times 1 squared over 1 squared minus 25. Is this the exact same answer? It's 2 over -24. So I know that I have what kind of a shape down here? Is it a cubic or is it a parabola? It's a parabola. So just nice and easy, guys. Just right through here. It does not have to be perfect. It's fine. Go through the intercept if you have one. I don't need you to be super specific, but I do need you to not cross the vertical asymptotes. Does everyone understand that? All right. Now let's go to the last section over here to the right of your vertical asymptote. Pick a number.
6.
Let's plug in 6. If we plug in 6, what's going to happen? I have 2 times 6 squared over 6 squared minus 25. Haven't we already had this problem?
Yep.
Yeah. This works out to be 72 over 11. Is that above your horizontal asymptote or below it?
Above.
It's above, so it's going to be up here. And that is the general shape of your rational function. Is it exactly perfect? Absolutely not. But it's the general shape. Hold on one sec. We will work on, tomorrow we're going to do 3 or 4 of just doing this. So you guys are getting the habit of it. Yes, sir.
How do you know it's a boomerang?
It's always going to be.
Okay.
The ones on the outside are always going to be boomerangs.
How do you know which way they're going to be facing?
Say it again.
How do you know like which way the boomerangs are going to be facing?
It'll always stay along like the asymptotes. Like it's not going to come here like this. Yeah, it'll always stay along the asymptotes. Okay, so what I wanted to show you is this is a question from WebAssign. The last one. It says vertical asymptotes, horizontal asymptotes, slant asymptotes, and holes. So you have to factor. You always have to factor first, right? You're going to find the vertical asymptote. You got to factor the denominator, whatever. If you notice here, guys, you're going to get, when you factor this, I factored it right here in green. You see that? So you set your denominator equal to 0 to find your domain and all that stuff. I got x equals 2 and x equals 1. But look at your asymptote. There's only an asymptote at x equals 1. Why? Because there's a hole. Do you see where the hole exists right here? Where the green crosses out? So I agree. I totally am with you guys to just write x equals 2. That's where your hole is, which is fine. But WebAssign is asking you to give the precise place of the hole. So the way that you do that is you plug whatever you found for your hole, x equals 2, you plug it into your factored right here, and then you'll find the y. But you don't have to do that on your test. You have to do it to get your answer right on WebAssign, but you do not have to do it on the test. So if you guys want to take a picture of that, I mean, it's in the video now, so you have it, but if you want to take a picture of it or whatever, it's there. Might be helpful.
Can you use the restroom?
Yes, you can go too.
What?
All right, so go ahead and look at WebAssign. Pull that up, try it. Some people finished it last period. Some of you that haven't even started it, that's not super. So let's get it started, and then tomorrow we're just going to practice, practice, practice.